Existence University is committed to free minds and to the highest quality of content, and as such, we will never take government or corporate financial support. The following is brought to you by Existence University merchandise, available at the Patreon page You Exist, and also by donations through PayPal or Patreon by viewers like you. Thank you.
The key to the next revolution in physics has been hiding in plain sight for over a century. Let's find out what that key is here on Inductica.
We've been living in sin so long, all the feels are gone. Fella stopped me on the street last night, said everything's
So what is the value of keeping your mind connected to the fact, knowing what's actually the case,
It seems your meal ticket is
knowing
gone,
what's true in
and
reality?
life goes on. I could never imagine something better. Yeah, right. Now you're cooking on high heat in the middle of the street. Roller coaster, take me to a better time. Let's go. All sing your high line with the roller coaster of life. It's time to all choose your timeline on the roller coaster of life. You seem to easily forget how to place your bet. When everyday life gets you down, you gotta steal the crown. Got to own it. Don't bitch and moan about it, please. God forbid you scrape your knees, and it's nothing to sneeze at. Oh, I've told you over and over again. You gotta get both hands around it and make your own plans. Roller coaster, it's taking over, it's about time. Oh, sing your high line on the roller coaster of life. You've got to all choose your timeline with the roller coaster of life. Roller coaster. I want to go down the rabbit hole, down the rabbit hole of life. And now it's about to leave. Oh, roller coaster.
So the ether was never disproven. Physicists simply preferred Einstein's explanation, that these effects were the result of the speed of light being measured as the same for all observers.
The loaded language here is crazy. Physicists didn't pick Einstein's theory because they thought it was neat. He is just 100% correct, hence how we have GPS today. Also, no one denies the ether, just the ether as the ether. We have what we call fields, and have done so since way before Einstein.
But let's remember, the ether is not just a hypothesis.
It kinda is. There's no backing theory or evidence to your ether.
Its existence is already proven by the existence of fields.
That is so dishonest. Again, it's like saying that miasma, bad air theory, is proven by germ theory as opposed to the truth that any appearance of miasma being true is based on the fact that germ theory is true. To say that the ether is proven by fields is a stolen concept.
Remember, fields are a property at a particular location.
Fields are properties is James's and James's alone own definition and no one else's. This is cult thinking, forcing his map of reality onto the viewers dishonestly.
And these properties can't be properties of nothing.
This is loaded language, gobbledygook, meaningless dribble.
Now, because they realize this on some level, modern physicists actually attribute these fields to something they call the quantum vacuum. But we got to remember, the word vacuum means nothing.
Vacuum literally means without air.
And it's not nothing. It's something. It has properties. Now, this isn't just a matter of semantics.
It is 111% just semantics.
So long as we say that these fields are properties of the vacuum, properties of nothing, then we can't ask what that nothing is. Nothing isn't something we can ask about.
Of course we can. We don't have to be rationalists that believe words cannot change without changing reality. Epistemologically speaking, we can ask what the properties of anything, including nothingness, is. If we find one, then the word nothingness is no longer representing the old version of that word, which meant not having properties. And of course, we would not want to scientifically call it nothingness, as we reserve that word for meaning no properties. So we call it the vacuum, a vacuum meaning lacking air. Or we call it a field, or we call it space-time.
Alternatively, if we decide to call it an ether, if we decide to name it as something...
What if we called it a field, or a vacuum, or space-time, or, better idea, let's call it Jerry.
Now we can ask, what properties of this something, of this ether, cause it to carry these fields?
Now we can ask, what properties of Jerry allow him to carry these properties, as fields are just properties, according to James. Let's call them the Jerry field having properties of having fields. Clearly, since we called it Jerry, that the properties of field having is likely greed, as greed is a property that a Jerry can have. I have used the Inducticus style of proof to prove Jerry must exist.
Now, in an attempt to answer this question, we can make hypotheses about how the ether might tie these different fields together, might tie all of physical phenomena together. Here are a few hypotheses.
We can naturally assume that Jerry and his greed properties have enough pockets to carry all of the fields
that you might be able to make right off the bat. Creation and annihilation interactions of quantum particles show us that quantum fields are such that when they combine, they can create other quantum fields.
When two objects in Jerry's pockets interact, they can make a new object, thus proving Jerry's pockets exist. Therefore, Jerry exists.
So, for example, an electron and positron can be combined to create a photon.
That is literally not even what is happening at all in that picture. That Feynman diagram is showing how two electrically charged particles cannot touch via the Pauli exclusion principle, and that the boson interaction is the cause of any electrorepulsion or attraction. Hence, why in the photo, the charged particles switch charges and continue to exist and move away from the interaction vertex.
Conversely, photons of high energy can often change into an electron-positron pair in certain circumstances.
Everything here, whether correct or not, is opposed 100% to James's theory of the ether. This is stolen concepts and frozen abstractions all the way down.
This tells us, think about what this means for the ether. If all of these things are an ether waving, then this tells us that the ether can wave in different ways. It can wave in an electron way, a positron way, a photon way. And some of these manners of waving can give rise to other manners of waving.
He's asking you to imagine that which you cannot imagine, and putting in its place his map of reality, a cult technique.
So perhaps these different conversions among these different waves will teach us something about the underlying properties of the medium which carries them.
There's an entire field of scientific investigation called the quantum field theory that covers all of this way better than James ever could.
What properties might the medium have if it's able to wave in these different ways, and if some of these ways can give rise to other ways of waving?
Absolutely meaningless gobbledygook jargon.
Let's turn our attention to gravity, which is the odd man out among the physical phenomena. Gravity, of course, bends the path of both light and matter.
And finally, let me show you that my entire modern physics videos were made to answer all of James's question from this video that he had made. Let us go on to gravity in modern physics. By me. It was this confusing little constant of proportionality that made people skeptical of Newton, for he is essentially stating that there is an atom on a planet in the star system of Proxima Centauri which is attracted to an atom in you. In fact, to every atom in you. By what means was there to suppose this action at a distance, his colleagues scoffed. Newton, however, didn't really care about that, because he didn't need to postulate a hypothetical ether in order to account for his ideas. He had math, and the math worked every time. Well, not every time, but we will get back to that later. We needed to find this gravitational constant to make the calculations really accurate. Knowing the approximate mass of the sun and planets, and their distance between each other, provided great measures without the constant. But to predict things to the degree, to a second, would require more precision, and the fact of the matter is that not having a constant will always lead to failure. The constant must exist. Enter Henry Cavendish, who found a way to measure the gravitational constant. An elaborate setup which was a type of replica to Coulomb's torsion balance experiment. As the formulas are identical, so too is the experimental setup, kind of. A torsion balance holding two 350-pound lead balls, suspended opposite from each other, which had two smaller 2-pound balls positioned around the larger balls. The smaller ball's attraction with the larger ball was the main focus of the experiment. The use of two each is to balance on the torsion wire. As the smaller balls and larger balls mutually attract one another, this puts tension on the suspension string, which causes the suspension string to twist. The structure eventually comes to an equilibrium, where the torque on the wire can provide a measurable value of gravitational attraction. Cavendish's results were not as accurate as we have today, but compared to everyone else in 1797, he was the closest. And he found that the force on the wire was 1.74 times 10 to the negative 7 newtons, and therefore accounting for the masses of the balls and the distance between them, Cavendish found the value of G to be 6.74 times 10 to the negative 11 meters cubed per kilogram second squared. Today, we know that that value is 6.67408 times 10 to the negative 11 meters cubed per kilogram second squared. Two of the mathematical calculations of planetary motion did not work even after Cavendish found the universal constant G, and those were the orbits of Uranus and Mercury. In 1843, John Couch Adams and Urbain Jean-Joseph Leverrier independently predicted that there must be another planet, as the discrepancies between Kepler's laws and observations of Uranus were not making any sense. Unless something else was pulling on Uranus from outside the system. Given the orbital mechanics of Newton, if you assume another body must exist, and it does, then you will be able to predict when it is going to pass near other objects. By 1846, the planet Neptune had been discovered, when Leverrier sent his colleague the position in the sky to look, and that colleague, Godfrey Gale, found the planet right where Leverrier said it would be. Mercury was then the only object that Newton's laws could not fully account for. So many speculated another planet closer to the Sun, and they chose the name Vulcan, for the Roman god that forged the weapons of the other gods in his furnace under the island of Volcano. This brings us right back to Lorentz and Einstein, so we return to Einstein in 1907. In 1907, Einstein assumes, quote, the complete physical equivalence of a gravitational field and a corresponding acceleration of the reference system, end quote. And, by doing so, also predicts that clocks dilate due to gravity, and that light should bend in the presence of a gravitational field. He did so by extending the principle of relativity to an object with a constant acceleration. A constant acceleration means that the velocity changes over time. If you imagine a frame of reference which is moving with the object, both of which are moving relative to the stationary frame of reference, we could imagine putting a velocity frame of reference at the location of the accelerated frame for each unit of time. If we restrict ourselves to the small changes in the beginning and set them all together at t equals 0, then after the first click, the s' frame and the sigma frame are now in location 2 together. If we synchronize our clocks in the s' frame, we know by special relativity that for this to be perceived as true for people on s', then people on s will calculate the front clock as being behind in time and the back clock as being ahead in time. After the next unit of time, sigma no longer matches s' or s. When the s' and s' frame calculate the difference of sigma's local time from their perspectives, they find that the local time of the object is equal to the total of the other two times, call it tau, times 1 plus the acceleration over c squared, times the distance from the observer. However, from the point of view of a single object that spans that length and exists in the frame of sigma, it is required to use the time tau, which appears as a normal functional clock to them. Einstein, having already assumed that we cannot tell the difference between being in an accelerating frame of reference and gravity, shows that we can replace the acceleration of the frame and the distance with phi, the gravitational potential, obtaining that clocks above the ground run faster than the clocks on the ground by a factor of 1 plus phi over c squared. Given this, Einstein then proceeds to show that that fact will have an effect on photons, that gravity will affect photons despite photons having no mass. Einstein showed that momentum is replaced by momentum times this factor, and likewise the speed of light is replaced by the speed of light times this factor. Therefore, Einstein was able to show that light rays that propagate with the x-axis are affected by the gravitational field, and that the light rays which do not propagate along the x-axis are bent by the gravitational field. It is important to note here that this does not mean that the speed of light actually changed, but rather that the accelerating frame's spatial coordinates are changing in a curved manner. The coordinate velocity of light changes, not the speed of light itself, which would be strange given that we need that number to calculate the appearance. This has a very important meaning in regard to Einstein's 1905 discovery that mass and energy are related, and that an object in motion appears to change in kinetic energy. More so, this discovery that even photons will be affected by a gravitational field helps illuminate the answers he was searching for. Einstein had previously stated that if you add energy to the object, for example, forcing a magnet near another magnet that it is repulsed from, that gain of energy will increase its mass. Einstein was now looking to show that if that object is a mass and the energy you add to it is caused by gravity, that the result will be the same. Given all of the above conclusions of special relativity, Einstein concludes the paper stating, quote, "This equation expresses the principle of conservation of energy and contains a very remarkable result. To each energy E in the gravitational field, there corresponds an energy of position that equals the potential energy of a ponderable mass of magnitude e over c squared. Thus the proposition that to an amount of energy E there corresponds a mass of magnitude e over c squared holds not only for inertial, but also for gravitational mass." End quote. In 1911, in the paper titled "On the Influence of Gravitation on the Propagation of Light," Einstein expanded the views he established in 1907, including postulating in the introduction of that paper that one can test his hypothesis by looking for rays of light passing near the sun, and you will find that they are deflected by about 1 second of arc. In this 1911 paper, Einstein shows that the gain of inertia mass from a gain of energy is identical to the gain of gravitational mass from a gain of energy, and that it is in fact the principle of relativity that merges the principle of conservation of mass into the principle of the conservation of energy. Given this, he states that if you send radiation energy from a high position above the ground down to the ground, and assume there is no gravity, but you find a way to accelerate the object to the ground, then, given the special relative nature of clocks and lengths, the energy that the ground receives will be greater than the energy sent. And by that same argument, the speed of light c at ground should appear to be equal to the speed of light on the ground plus the speed of light at a given gravitational potential phi divided by c squared. And therefore, he writes, quote, "The principle of the constancy of the velocity of light does not hold good in this theory in the formulation in which it is normally used as the basis of the ordinary theory of relativity. That the velocity of light in a gravitational field is a function of place. That light rays propagated across a gravitational field must undergo deflection." Einstein then states how we must model this by returning to a plot where light is constant, and through Huygens' principles of light, we deflect a plane of light by using circles and taking the flat spacetime, and we get the angle of deflection. Einstein then concludes that, quote, "A ray of light traveling past a celestial body undergoes a deflection in the direction of decreasing gravitational potential, and thus in the direction towards the celestial body." Everyone wanted to prove this was either true or false, and given that they had stars and a sun nearby, it seemed pretty simple. First, we just need a solar eclipse, so that the sun does not blind us when we look near it. Then we just need to measure where the stars behind the sun are. Then we wait for the sun to move from in front of those fixed stars and check again in 3 months to see if the relative distance between them changed when there is a massive object between them and us. Well, it was not that easy, because if you do any astronomy, you know that clouds will ruin everything. In October 1912, during the first solar eclipse available, it rained. So they tried again August 21st, 1914, and again, clouds. Then, and you'll know why if you are a bit of a history buff, you'll notice that the next few years of science into the angle of deflection of light caused by massive celestial bodies stopped in order to start working on science for projectile weapons and flying machines and big heavy armored vehicles. In 1916, Einstein proposed 3 tests for general relativity, which subsequently became called the classical tests. The first was that the general theory of relativity properly calculates the precession of Mercury's orbit, predicting an extra 43 seconds of arc in its precession. Second, light will be deflected by the sun. Third, that light escaping from a star or planet will be redshifted, meaning its wavelength will appear more in the red section of the visual light spectrum. It was already established by 1882 that the measured precession of Mercury was approximately 43 seconds of arc. In May 1919, Arthur Stanley Eddington was able to prove Einstein's second test for general relativity, finding the light from stars of Taurus from behind the sun that had deflected at the angle that Einstein had predicted. Finally, in 1925, results for measuring the star Sirius proved to have been redshifted. In 1959, the Pound-Rebka experiment proved Einstein's gravitational time dilation here on Earth. Einstein's theory of general relativity was also able to predict the cosmological constant, universal expansion, the Big Bang, the cosmic microwave background, black holes, and gravity waves, all of which have been demonstrated beyond a reasonable doubt today. Thanks to these discoveries, global positioning satellites are able to keep proper time on Earth by adjusting their on-board atomic clocks with a special and a general relativistic shift to counteract the velocity and gravitational potential of the satellite and its clocks. If it were not for Einstein's general theory of relativity, any satellite we threw up into space with a clock on it would very quickly become out of sync with our clocks on the ground, and our GPS would tell us to drive into the ocean. If that which Einstein's general theory of relativity predicts does not actually exist, then the global positioning satellites above Earth would have no reason to time dilate. Putting it all together. From Earth, without ever leaving the planet, it appears that the Earth is flat, and when you walk all the way around it, your feet never leave the ground and start walking on the ceiling for half of the trip. So it appears to you to be horizontally in front of you forever. But if you leave the planet and go hang out on the moon for a while, and you watch your friend walk around the planet, you see him walking around a ball, like a bug on a basketball. Likewise, up close, i.e. locally, all experiments of light are in a flat spacetime, and it's at its universal constant velocity, moving in a straight line. If you get a global picture, however, things start to become a little more complex. Given that we are doing our experiments on Earth in relatively tiny observatories, we cannot see the curve, just the final results, which appears to us as to have arrived in straight lines. Mathematically, then, we need to include a thing which prevents us from forgetting that the universe is not entirely flat, which will keep our lengths accurate to reality. The mathematics required to move between flat and curved spacetime are tensors, which is not something we are going to get into. All that needs to be said here is that a new metric was formulated which captures all of the geometric and causal structures of the space-time ether, meaning that it can be used to define notions of time, space, distance, volume, curvature, angle, and temporal separation. Einstein required using this new form of mathematics in order to better describe the universe.
Now think about this. If light and matter are just waves in the ether, then perhaps gravitation is a bending, not of some abstract space-time, but of a very physical ether.
1, who said it was abstract? And 2, why not a very physical space-time?
If gravity is a bending of the ether itself, it would explain why it causes the path of ether waves, light and matter, to change their path.
This is like saying that if a tablecloth has stripes on it, then the bending of the tablecloth will bend the stripes. Which, yeah, okay, but that's not actually saying anything more than the tautology that bending a line is what happens when you bend a line.
Perhaps this is the reason that physicists have been unable to quantize gravity for the last century. Perhaps it's because gravity is not a quantum field to begin with.
This is dishonest. Only a small amount of physicists actually hold that the gravitational field is quantizable, and they do so for much better reasons than James is allowing them to. This is just cult thinking on his part.
Perhaps the quantum fields are some property of the ether, which is able to vary in the more and the less, it's able to wave, and gravity is a bending of the ether itself. Now, I have to emphasize, all of these are just both of these are just hypotheses.
This is James's Molten Bailey. He is 100% wrong. And when you prove that, he can now say, well, I said it was just a hypothesis. However, he will use that hypothesis again and again without revision or addressing the criticism, usually as just playful thought experiments.
But the point of presenting them to you is that thinking about the actual medium opens doors towards a deeper understanding of these phenomena.
Given if he simply promoted to you to attend university physics, you would also discover that the science of the vacuum is a topic of science and physics. So, the true purpose of this video is to begin to instill his map of reality on you, so that if you fall for this video, he can drag you down the rabbit hole, forcing you to pay for hidden insider secrets.
The true purpose and the real power of science is the ability to identify and control hidden facts which influence the phenomena around us.
This is Science on Magic.
Early chemists were not content to simply document the different ways that chemicals can change. They went on to discover the underlying reason that they change.
This makes no sense, because 1, it's false, and 2, it's quantum and relativistic.
Because they are atoms that join into molecules.
That's literally not even making his case.
This deep knowledge has enabled us to enjoy custom materials, such as specialized polymers in cars, the semiconductors in computers, and catalysts, which speed the production of life-saving drugs.
And now he's using quantum products to deny the usefulness of quantum physics. Cool.
All of these are novel combinations of chemicals which would never have been discovered without understanding the fundamental way chemicals combine as atoms and molecules.
And it just so happens that chemists use quantum chemistry. Interesting, isn't that?
Just as the chemists of the late 1700s were right to look for the underlying nature of chemical reactions, physicists today must seek to understand the medium which carries quantum and gravitational fields.
We do. Quite well. The issue is that James denies they exist so that you will buy his books.
If the atomic theory gave us mastery over matter, then just imagine what kinds of powers we will enjoy once we understand the medium which plays a role in all physical phenomena.
This is just the selling of a cult utopia.
What other evidence can we gather about the ether? What special methods will be needed to discover the nature of this elusive yet ubiquitous medium?
A bachelor's degree in physics is a good place to start. Not fighting 2,000 years of science is another great place to start.
These are some of the questions Inductica will answer in further videos.
It is impossible for him to achieve this goal. Existence University is committed to free minds and to the highest quality of content, and as such, we will never take government or corporate financial support. The following is brought to you by Existence University merchandise, available at the Patreon page You Exist, and also by donations through PayPal or Patreon by viewers like you. Thank you.